This video is going to cover timelines. I'm sorry, non-animators. If you're going to be using blueprints, at some point you're going to have to deal with learning timelines. At least this way, this is safer. I'm not going to spend too much time on discussing timelines. I'm going to show you kind of how to create like maybe a timeline that triggers a light, but I think that's going to be something easy to kind of work with. Let's go ahead, and I'm going to go ahead and kind of create an event begin play here. I already made one up. Let's go ahead and deselect some of the stuff that we have over here so we're not messing around with that too much. Alright, compile save. I'm going to grab an event begin play node, and I'm going to right click the background here, and I'm going to scroll all the way down, and we're going to go ahead and grab a timeline. Awesome. And I'm going to go ahead and call this intensity. Cool. Congratulations, you've made your first timeline. Now double click it. Welcome to hell. Okay, it's not that bad. It's like hell, but like there's ice cream. I'm not a fan of animation as a whole, but I kind of have to understand a little bit of it in order to kind of work within the engine. But I'm not an expert on animation at all. I'll just be honest. It's just one of those things that kind of flew past me. So now that we're in this window, we can see that it's an empty window. We see that up here. We can navigate to the timeline, and we can always navigate to the event graph. And if we end up closing the event graph, or excuse me, the timeline, we can go ahead and double click to open up our timeline again and get it working properly. As you can see, there's a bunch of different elements that you can use. Let's go ahead and talk about them as we go through them. I'm going to go ahead and very quickly add something called a float track, or rather an F track. A float track controls essentially a number of numerical values that you can use to control single float values. So, for example, I'm going to go ahead and apply this to a light, and the easiest thing to understand is that because we can control linear numerical values, what is intensity in a light bulb? A linear numerical value. Awesome. So let's go ahead and call this light intensity. Cool. Now notice how I use my variable nomenclature inside of blueprints. You can use underscore if you want. It doesn't matter. What matters is regardless of what you do, that you are consistent all the way through. All right? That's going to be more important than trying to figure out what you want to do. Make sure that whatever you type out is going to be the thing that you're going to be utilizing from here forward, because it helps with your syntax as long as you're able to kind of work with it, right? So the nice thing about this is we can add keyframes, or rather keys, to this particular graph by holding down, say, Shift and left click. This allows us to create keys that we can work with. I'm going to add a couple of things here. So I'm going to go ahead and these are time and value sliders. So at 0 seconds, I want a value of 0. So I'm going to start completely dark, and I'm going to shift click and add another keyframe. And then at 1 second, it will also be 0. Let's go ahead and talk very quickly about how we can navigate this viewport. Right click allows us to move our viewport as we see fit. Scroll wheel lets us scroll out. Left click allows us to marquee, just like if we were in an orthographic view. Just like we were in a blueprint, right? Alright, so what I want to do with this is I want to make sure that my keyframes understand what I'm going to be doing with my values here. Now there's other things that we can talk about here. We can talk about vector, which controls things like direction. An event track, which allows us to set events. Color track, that allows us to change colors. We can add a selected curve asset, which means if we already have a curve that is saved and we have been using it over and over again, we can go ahead and select it from the content drawer, but we don't have any selected in here, so it's fine. We've got the length of the track. Right now that's going all the way up to 5 seconds. As you can see, our track blacks out after 5. We have the ability to use last keyframe, which decides whether or not the last keyframe is going to be used for the purpose of smooth loop animation. We have autoplay, which allows us to play naturally as soon as it gets an opportunity to play. We have loop, which loops the animation, like so. It doesn't go forward, back, forward, back. Replicated is about discussing whether or not this timeline is available over the network. Ignore time dilation Time dilation is basically the ability to go into slow-mo time and whatnot. For example, if you have a mechanic in a game that lets you slow down time, if you're already slowing down time and that's based on a duration that's using like a bar or like a resource to slow down time, wouldn't you slow it down twice? You would. So you can ignore other time dilations and have this run based on our real world time or in-game time depending on what's happening. We have a physics drop-down to select what physics group we want to run this in, or rather what tick group, because ticks can be either for physics, during physics, after physics, or any kind of, say, update after physics is already taken care of, like when an object is coming to rest. This is a little bit more advanced than this particular course needs, so we'll leave that alone for now. And this doesn't do anything, it's just marked as tick group. I wish this was labeled a little bit better. Over here we have whether or not this curve, like for example, we have a curve here that we can use. We can use a curve that we have selected. We can browse to this particular curve, or we can convert this to an internal curve, which allows it to be saved and compiled as an asset or an element. This allows you to convert an element to a saved curve, so to speak. We're not going to worry about that. Synchronized view, I'll showcase what that does here shortly, but synchronized view allows us to modify both of these at the same time, or we can asynchronize them depending on what's happening. Any object with the synchronized view turned on, both of them will allow us to modify the graphs. Let me close this. Actually, let me delete this one. This doesn't actually do anything. It looks like it's going to delete, but what it does is it tries to save it as an internal curve. We don't have to worry about that. Let's go ahead and delete this. Cool. I'm not going to worry about that either for now. Alright, that's pretty straightforward. We don't have to worry about internal curves for now. I'm not going to rename this either, and then we can delete this. And let's not worry about height. Height's not a big deal. Alright, let's go ahead and add some more keyframes here so that we're actually making something that looks good. Let's add a third keyframe here. I'm going to hold Shift and left click, and this will be at, say, a value of 3 seconds. I'm going to have a light value of, I don't know, 350 candle power. Oh no, what's happening? These buttons here will allow us to zoom to fit our horizontal and vertical based on how many keyframes we have, which makes it super useful. And then I'll add one more keyframe, and this one will be at 5 seconds. Value of 0. So what's happening here is from 0 to 1 second, we have no intensity. From 1 second to 3 seconds, we have an intensity increase of 350, and then from 3 seconds to 5 seconds, we're back down to 0, and then it holds again if we loop this. So we'll loop from beginning to end, beginning to end. Alright. So that's pretty straightforward. The nice thing about having elements like this allows us to control their overall intensity with the amount of information that we have. I'm going to go ahead and save this for now. I'll compile and save. And we're going to go ahead and pop back out into the event graph here. We're going to make some stuff. Alright, I'm going to go ahead and grab and actually create a light here. And in order for this to kind of work a little bit better, I think what I'm going to have to do is I'm going to have to lower the light intensity for these. Let's go ahead and put my details panel here. 0.1. I'll grab my skylight. 0.1. Cool. Okay, that'll be fine. And let's go ahead and grab a point light here that I can use. And we'll leave that there for now. So I'm going to go ahead and have that selected to make sure that I can go ahead and reference it. And we're going to go ahead and open up the level blueprint. And I'm going to very quickly go ahead and grab my reference to my point light here. Cool. And I'm going to drag this out. And I'm going to set intensity from the light component. And then we're going to use our timeline here to control how this is going to update. Let's go ahead and on event begin play. Okay, let me explain these elements over here for the timeline, and then we can move on. Play is just your normal playhead. On event begin play, we'll play. However, we can also force the timeline to play from different elements. Play from start, we'll force it to play from wherever the start is. On event begin play is pretty safe because this will play from the beginning, but you can also interrupt the play of a timeline using other nodes or other elements or other executables, and then it will play from wherever the playhead is. So for example, if we are here and then we stop the playhead at 2 seconds, for whatever reason, when we hit play again, it will play from wherever the playhead is. Play from start means that regardless of where it is, it will always restart the track from the beginning of the play, from the beginning of the track over here, not where the playhead was. Stop does exactly just that. It creates a conditional where it just stops the timeline wherever the playhead is. Reverse reverses a timeline from wherever the playhead is. Reverse from end is the same as play from start, where it reverses the playhead, but the playhead starts from the end and moves to the beginning. Set new time allows you to start the playhead at any point in time, depending on what second there is. So if we are setting a new time, this will activate this variable here, and it will set whatever new time this happens to be in the variable up here for time. Update is once this is playing out, it will pass along its values, and this is actually what we want to do. We want to update our intensity. Finished means that this only executes once the timeline is finished. Direction sends off what direction the timeline was traveling in, either forward or backwards, by the time it finished its update or by the time it's currently parsing. So if we need that direction for whatever reason, meaning what direction the playhead is traveling in, either forward or backwards, we can get that as a variable, and that's an enumerator. And of course, look at that. Light intensity. Let's go ahead and plug this in. Cool, cool. Let's clean this up a little bit. Let's compile. Let's hit save. And let's go ahead and go back into the actual demo map. Now we can actually clearly see this light. I'm going to set this light. I'm going to instantiate it at 0 candle power just to be in line with everything that's happening. And I'm going to set it stationary. Because remember, stationary lights can increase or decrease in intensity without having to worry. Let's go ahead and play. Awesome. And that will play once without looping. Again. See, it says paused, but it's not actually paused. It will run once unless it's reset for whatever reason. So right now the playhead is paused because it has finished the play and it has completed it. Once the playhead is finished, it will go back to the very beginning and wait, unless it's told otherwise. Let's go ahead and play again. Yeah. Let's see how this is running. Alright. So we see how during play, sorry, I didn't misspeak. I was referencing the graph at the stop. So if we stop, we see that it goes back. I apologize. Let me correct that. So when we hit play, we can see that the blueprint is running in the background, and then once this is finished, this is considered at the end of the playhead. This is done for all intents and purposes, and it updates to our final set. This will not reset unless it is told to play from start again. If something resets it, for example, after a delay, we might be able to play it from start again if we get another event trigger like a key press or a button press. Or we might be able to set this up again to have a separate button press that plays it from start and then plays it again. It really just depends on the context of what you're doing with your timelines. But timelines can be incredibly useful for setting up elements and events that fire off at different times. See, again, if I simulate, we can see very easily that this timeline event is set up to change the intensity of this one particular light. And you can stage these to help you kind of create something that can look a little bit different. Is that all I wanted to cover with timelines? I think that's everything I wanted to cover with timelines for now. Timelines become a lot more important. Ooh, I should talk about lerps. Yeah, let's talk about lerps. That'll be fun. All right, let's talk about lerps. Let me go ahead and stop the simulation here so we can keep going. Let's go ahead and I'm going to go ahead and unplug my light intensity, and I'm going to go ahead and grab a linear interpolate. And I'm going to set up some new intensities here. Let's go ahead and set a couple more variables. I'm just going to create two new variables. I'm going to call the first variable min intensity, and we're going to go ahead and call that a float. And then the other one will be max intensity. And we'll also go ahead and call this a float. And we'll compile them both. Alright. So I've explained lerp before with materials. But let's go ahead, and I'm going to go ahead and hold down Alt and drag up, wrong Alt. I'm going to go ahead and hold down Control. There we go. To make these both setters as opposed to getters. And we're going to plug in our minimum max intensity here. Let's go ahead and set some values in here. I'm going to set the value for max intensity at 200. And the minimum intensity will stay at 0. Alright. Let's go ahead and grab the light intensity over here and go plug this into the alpha. And I'm going to go ahead and open up this timeline. And I'm going to set this particular value here from a value of 350 down to 1. And then I'm going to reframe this. So, at 3 seconds, we hit a value of 1. Double check to make sure both of these are correct here. Okay, yeah, that looks good. Alright, I'm going to compile here. So, let's talk about this. And let's go ahead and change this max intensity to like 500. That way it makes a little bit more sense for you guys. So, we've changed our timeline. Let me make sure we're in the right thing here. Okay. Yep. So we've changed our timeline here. Instead of changing the intensity in here, where we were setting the intensity up to, what was it, like 350? And now we've set it to a value of 1. This is now at 3 seconds passing along a value of 1. Let's go ahead and check on the event graph. We're now taking this information and we are piping it along. Let's go ahead and plug this in correctly. Sorry about that. We're piping this information along to this lerp node. I would ask who here remembers how a lerp works. So a lerp defines a point. Hey, sweetie. A lerp defines a point between A and B. Don't be confused by this term called alpha. Alpha is just which percentage of the point along A and B we are. At a value of 1, we are going to be at the maximum value, that is B. At a value of 0, we're going to be at the maximum value at A. What if our light intensity was set to a value of 0.5 here? So right now it's set to 1. What is between 0 and 500? 250, right? So if we set this value over here to 0.5, this light's value, the value that would be coming out of this pin right here, would be the linear interpolation of this minimum max intensity based on our timeline scalar, which is set to 1. Or excuse me, which is set to 0.5, sorry. In this particular example, this value is set to 1, which means that it's going to bias all the way from A to B, but B is currently set at 500. Let's go ahead and compile, save, and test. Linear interpolates are a great way to utilize timelines if you don't want to hard code seconds and you only want to hard code values into your timeline. In this particular case, we're only hard coding on and off. We're hard coding the value of 0 here. So from 0 to 1 second, we have a value of 0. From 1 to 3, we have a value of 1, which means that the light is going to ramp up aggressively to on, and then the light is going to aggressively ramp to off. Right? So that's what this means. This 1 here means it's going to reach a value of 1, whatever this 100% value. Think of what this 1 is 100%. Whatever 100% of the max intensity is supposed to be in the B for what lerp is. So lerp designates the difference between A and B, and alpha designates what the actual point or what the actual number is supposed to be. So 50% of the distance between 0 and 500 is 250. In this particular case, I have this set to 1. So 100% of the distance between 0 and 500 would mean that the light gets to be 500. It then takes that value of 500, passes it along through the return value, and then puts up our new intensity. That's how you can utilize lerps with our intensity sliders in order to create some more interesting effects that are controlled by, say, variables. And let's say at some point we have a node that sets a new maximum intensity, and instead of getting that, we set a new maximum intensity. We put this along the line like so. Something triggers this particular, right? We've got our new max intensity, which we're setting, and we're setting it to maybe, I don't know, 100. So something could trigger this. We'll compile. So now our max intensity is going to be overridden. Notice how it's not as bright. And even though this is already hard-coded at 500, we're only passing along a value of 100. Let's go ahead and stop that. Let's make it a little more obvious. Compile. You do not need to save in order for it to run, but I like to save whenever I'm working quickly sometimes. Oh, it's so faint. But you saw it. That was a little tiny. There was a little tiny lump of light. Let's do like something a little brighter than that. There we go. So you see how we can use variables, we can use lerps, we can use timelines to change the value of elements from the level blueprint. We've learned how we can reference those elements, we learned how we can bring them in, and we learned how we can change them. All right, that seems fairly straightforward.